So being able to fix stuff has got a lot to do with being able to use the information that you have to do what needs to be done, and that's an important part of it. And I had a 78 Dodge pickup that I looked at one time. You know, sometimes things just don't seem to make a whole lot of sense. This inoperative left-hand turn signal, and this truck wasn't that old at the time. And you know, everybody knows how these old bimetal flashers work and everything. But after checking the bulbs and the wiring and the grounds and all that, I discovered that the flasher was the only thing that needed to be replaced. And that doesn't usually happen on just one side. Typically, if you've got one of these flashers that's fouled up, it will, you know, won't flash at all or whatever. But that one there would work on one side but not the other. And it probably, the original flasher was carefully tuned to how many amps the bulbs were pulling, and it may have had something to do with one side pulling just a few more amps than the other one or something like that. You know, that's possible. There was this 66 Cadillac convertible. My brother got into the kick of driving convertibles and Cadillacs and stuff for a while years ago, you know, back in the 80s. And he had this beautiful, this is not exactly a picture of his car, but it looks exactly like the car he had. Interesting thing about this car was the top was operated by a hydraulic pump that used brake fluid. Some of you might be familiar with that. But I dug into the passenger side. There was a power window issue that would come and go, and as I dug into that, I found a pushed back pin and a connector in the left kick panel, and from the condition of the harness and the connector, it appeared that that thing had been that way ever since that car was brand new, which is very interesting to me because this was way on up in the late 80s when I found this. He also had a 78, well, let's stop for a second and look at that wiring schematic. That's the wiring schematic for that Cadillac, you know, and it was all on one page back then. You know how they did that. I thought that was very interesting, a little slide I just put in there. Well, my brother had a 78 Cadillac like this one here. Again, this is a picture of one like it, but it wasn't exactly the one. And he had, you know, he always liked to keep his wheels aligned and his tires rotated and all that kind of thing. But the car had some radio noise all of a sudden that was, you know, static on the radio. And so I said, well, let's bring it over and let's have a look at it. And we was also working on one of the power windows and everything. And I was checking, you know, antenna grounds and stuff like that. And he happened to notice that one of, you know, because it had spoke wheels on it, and one of the wheels had a damaged spoke, he realized that instead of rotating the tires from front to back, they had rotated them crisscrossed, which is not a problem nowadays, but back in those days, when radial tires, if you remember, if you've been around long enough, there was a time when radial tires didn't ever need to be put on an opposite side of the car than they originally started running on. And so, and I actually had some radial tires blow out on me because of that, because I had just maybe taken a radial tire, you know, rotated the tires from side to side, front to rear and all that. Nowadays, like I say, that's a total non-issue. But back then, those steel belts had an issue with that, and what we figured out when we rotated his tires back to so that that tire with the bent spoke was back on the same side of the car that it started out on, that all radio noise went away. So apparently those steel belts were making some kind of radio frequency interference or something. I don't know. I mean, I saw that happen. This is not something, you know, that I was, you know, heard about from somewhere else. I actually experienced it, you know, by doing the heavy lifting. Well, this 80 model Lincoln that belonged to some people that worked with my mother when I was at the Lincoln dealership over there, it would buck and skip exactly 5 minutes after a cold start every time. But it would never do it again while the car was warm. And you shut it off if it got completely cold. After a cold soak, 5 minutes into the drive, it would buck and jump. Just a couple of 3 times. And what I got to looking at that, I found out that this crank sensor right here, that right there, you might notice it's still got the same color wires going to the crank sensor, but that crank sensor, one of those pins was pushed back so that it was only making continuity part of the time. Now, how that made it act up after 5 minutes of driving every time, unless there was some sort of expansion going on because of the heating up or whatever, I always wondered about that, because when I put that connector back to, snap that thing back in there and put that little red wedge in there like it was supposed to go to held that connector, they never had that problem again. It's really crazy. Then you got this one 6-volt vehicle I heard about from the 1950s that would spin and wouldn't start with the key, but if you pushed it while it was in gear and popped the clutch, it would fire up immediately, but you couldn't start it with the key, and that was turned out to be a bad engine to frame ground on that one. Now this little 2003 S10 was a humdinger. Yeah, and I talked about it on a previous video, but not in the detail I'm going to hit you with today. It had a lot of other issues that had been ignored until it developed a headlight issue. And if somebody's planning to drive at night or in the rain, you got to have the headlight. So I was thinking, well, this will be a slam dunk. How hard could it be to figure out a headlight problem on a 20-year-old domestic vehicle? Well, the changing world of vehicle lighting goes like this. Back in the day, you had a headlight switch going through a dimmer switch going to the headlights. Now that dimmer switch, I've got it showing with a stalk, but a lot of the old ones up until 1991, Ford had a dimmer switch on the floor. But the simple fact was the headlight switch was actually carrying the power through that to the headlights. Well, nowadays, and beginning in sometime in the 1990s, maybe the late 80s on some models, you would have a headlight switch, multifunction switch, a body computer, relays, and headlights. Okay, that's how it was on this one, and they work various different ways. But you might notice the way that the body computer works. It gets a signal from the headlight switch about what it's supposed to do. The body computer also operates the stop lights and a bunch of other stuff. Well, what we wound up with, we hadn't tackled one of these before. And the initial concern was the headlights would only illuminate when you were on flash to pass. Occasionally they'd work normally, but usually they wouldn't. The daytime running lights wouldn't even work. So the owner of the truck couldn't care less about the daytime running lights, which is not required in this part of the country anyway, but he just wanted to turn on the light switch and see headlights come on that he could brighten dim and see where he was going at night. So I wanted to see if power and ground were available at the bulbs with the circuit energized, and we traveled that path. We got sidetracked when we found out we only had ground at the right front headlamp. With the bulbs unplugged, there was no ground at the left front lamp, but with the right front bulb connected, we had a ground, which confused the student I had doing the work and me too. So we waded into the wiring schematic, which became even more confusing. And folks who are familiar with this platform are already smiling, I imagine. But one of the maddening things about so many of today's schematics is they had these wires. Now, I actually simplified this schematic because one of the problems that you have with these schematics is they've got so many different numbers and words and all kinds of stuff. And it's stuff you need to know, but just for theory purposes, I'm looking at it this way. So I teach my folks that in most cases on a schematic, power comes in from the top and ground comes up from the bottom of the diagram, and that's usually the case, although I've seen it violated a few times on isolated schematics for one reason or another. Now on this headlight switch schematic right here, you might see that this power is coming right here. When that switch goes to the headlight position, it goes down here to what this means is this body control module can actually supply power from this rail to the headlamp relay coil supply circuit independently of the headlight switch, which is necessary because of the daytime running lights. You also might notice there's an ambient light sensor here that's used by the body control module for the headlamp switch. For the body control to use to turn on those daytime running lights. You know how that does. Now the headlamp switch off signal comes in here, and typically there's going to be a current drop in resistor right here, and it will be the voltage that, this keeps it from when that signal goes to ground, you know, basically if you look at this, see this is a ground. All right, and so whenever you turn this over to there, it grounds this. And that's telling the body control module that you turned off the headlights, right? All right, now let's watch this thing get more interesting here. Okay, so what you got right here is you've got the headlamp power relay, but you might notice that this comes from the power on the previous page. Let's back up. All right, see this, watch this A here. All right, power, turn on the headlights, power comes in through here, or if this decides to fit. Okay, now watch this, look at this A, see that A right there? Okay, now then, now look at this, look at that A. Coming in from the bottom, which confuses you if you're used to seeing grounds coming in from the bottom. See how that one does? That ground's coming in from the bottom. All right, this is coming in, and it turns on the headlamp power relay, which basically comes from a B plus stud up there, and it shoots power to these lights right here. All right, you see that? All right, so it's going to both of these. That's the right headlamp, and that's the left headlamp. So you basically, if that headlamp power relay is on, you're going to be feeding power to this light and to that light. All right, but look up here. This right here, the daytime running lamps relay, does something very peculiar. It acts like those fans, those two-speed fans, and it's going to operate those lights in series when the daytime running lights are supposed to be on. Rather than having a ground that's fed to the lights all the time, it's going to force the power to go through one light bulb before it gets to another. All right, now this right here is your multifunction switch. See, there's your daytime running lamps relay. There's another. It depends on this RPO code. See that ZR2? So you got to pay attention to your RPO code, because an RPO code is not mentioned on this previous. See that? This says daytime running lamp relay domestic. See that? All right, now this one here is not the same daytime running lamps relay. It's only found on one. And you notice up here, you see this RPO code referenced here and here, right? All right, so look at this ground right here. Whenever that relay is at rest, then this ground is going to go through here. And look at that. Without ZR2, that ground comes from the relay block body. I mean, from the body relay block. From this one here, you see it's an alternate current path. It's coming through the dimmer switch. So you're basically feeding a ground through these. And this is going to the headlamps down here. See those lettered arrows? All right, and so they basically are going to have this, the pointing toward the ground, basically, is what it amounts to. All right, and so that's, you notice how it's pointing toward the ground? Well, this is pointing toward the ground too, because it's going, you know, because of the way the headlights are in the circuit. All right, so then you got this headlamp grounding relay. Look at this nonsense. You got this relay right here, and so the headlamp grounding relay's at rest. See, when it's not energized, there's your multifunction switch. All right, let's back up to your multifunction switch here. All right, where is L? Let's see if we can find L coming from the multi. Oh, look at there. Multifunction switch L, right there. See that? All right, now let's go here. That's coming from the multifunction switch. So the multifunction switch is going to be getting this ground from right here. It's going to go through the multifunction switch, and let's back up and look at that again. And so that's where it gets that ground on the ones that's not a ZR2 RPO code. And so you can see how confusing this is. I mean, this is just really incredible. All right, and so then you got your DRL relay, daytime running light relay coil down there, right down here. See, and of course you got your park brake switch. But the body control module has got his fingers all over this thing. That's just the way that works. Now this is when you put all these together. The grounding relays normally close contacts deliver a ground to the multifunction switch when the relay is not energized. This relay is only energized to the multifunction switch in daytime running lamp mode, and that's this relay right here. All right, the multifunction switch feeds that ground to the headlamps, which are fed by the headlamp power relay, which is on the top left, right? Okay, now, See that? See, there's your multifunction switch right there. That's what that arrow is pointing at. Okay. The wiring is slightly different depending on the RPO code, but the daytime running lamp relay operated by the BCM changes the high beam headlight circuit from series, the RL mode, to parallel. Now, in their defense, they did put this here to help you out a little bit, so they could tell you when the relays were on and when they were off and all that. But fellas, do you think that you could probably come up with something that would work better than what they've got here? Because my goodness, when something goes wrong with this, you notice all three relays are controlled by the BCM. This is ridiculous. Ridiculously complex. Well, we wound up figuring it out because what happened was we wound up putting a multifunction switch on it, and that turned out to be what the problem was, but it wasn't easy to ferret that out. Now, I just giving you a little look at a RPO code sticker here. This is not the one from this vehicle. This is just a standard RPO code sticker. And looking at that, you know, I've actually had the GM people say, look, the RPO code is, you know, what you got to look for that. You got to find the one number that they're looking for in this whole list. Now, somebody that fools with these RPO codes all the time, you know, will recognize that there's pretty much, these things are pretty much in alphabetical order going across the top. Right there. Then they go B, C, then the D, and then E, X, G, so on and so forth. So you can track it down if you're used to looking at these things. This thing's usually in the glove box. And we've had to go look for these before. But that's something you've got to have if you're going to get the right parts for these GM cars of this vintage. We put the multifunction switch on it, and that took care of the problem. It was a real wild ride getting there, though. So, anyway, that was just an interesting little thing I wanted to show you there. This one here, we had a problem with the transfer case. This chain, you've probably seen this before. The chain wore out to the point to where it actually wore a hole in the transfer case. And I said, you know, rather than, you can actually buy a kit that comes with this front cover and a chain, so that you can actually recondition that transfer case. There are kits you can buy to do that. But we opted to just, you know, go to the salvage yard and get another transfer case. LKQ brought it to us. And that's fine. You get it. It comes with no oil in it. And so what we had to do was whenever we put the transfer case on the vehicle, and this picture is actually taken from the wrong angle because this was the bottom of the transfer case. After we filled it up with oil, we already had it in there, everything done, put oil in it was the last thing we did. And doggone if oil didn't start coming out between the case halves. All right, so what are your choices here? I mean, you can basically go ahead and pull this transfer case back off of here, do a bunch of extra labor, and reseal the transfer case so that this stops. Because if that oil dribbles out of the transfer case, it's going to destroy it. So this is a sort of a dirty hand that we got dealt, you know, with this transfer case that we bought that was salvage yard. And the thing about it is the salvage yard people, they couldn't care less about this, you know, because in their mind, they drained the oil out of it, they steam cleaned it, and they sent it to you all wrapped up in plastic or whatever. Anyway, that transfer, that was on a Tahoe, by the way, on a 97 Tahoe. And we basically did that reminds me of a transmission swap we did on a four-wheel drive expedition a couple of years ago. And it did really good for about a month and then came back making a racket, and it turned out it had a cracked flywheel. Now, should we put a new flywheel in one every time we have the transmission out? I don't know. Maybe it wouldn't be a bad idea if you can get a customer to buy it and a new flywheel is available. On another one, there was a 99 F-150 that came in with a ruined rear end due to failed pinion bearings. It had been driven that way for quite a while. And you can see how those failed pinion bearings had caused that pinion gear to just chew up that housing, right? I mean, that differential carrier. And so we went ahead and replaced the rear end on that one. We got another rear end in there. Now, they had a little bit of a problem because the backing plates on the rear end were all banged up, so we basically had to take the backing plates and everything off both ends of this rear end assembly, and we had to, you know, do that. But that's some of that salvage yard stuff, you know, when you get it sometimes. Like engines, when I get an engine from a salvage yard, I always like to pull the valve cover off and look and see how much sludge is in there. And if I see a lot of sludge under the valve cover, I like to pull the pan off and get the sludge out of that and get this, as much sludge out of there as I can. Because sometimes if it came from a mom and pop car and it gets hot, that sludge may melt and drain down in there and clog up the screen. And next thing you know, you got to come back because the sludge got down in there and clogged up the screen and messed everything up. Undid all the work that you did really fast. Now here's some little ignition quickies. There was a Suzuki XL7 that came in for an exhaust leak. And we found out somebody had started trying to cut the exhaust to steal the cat. I got that picture here somewhere. Let me get that. See that right there? They started trying to cut the exhaust to steal the catalytic converter, but decided to stop only part way through. I showed that on a previous video. But after I fired up the torch and I coat hanger welded this thing, the exhaust leak shut and smoke checked it to make sure it didn't leak. We don't have a wire welder there. You know, they had that over at the automotive, at the welding shop, you know, in the welding department. But I just went in and did it with a torch and a coat hanger. But the driver hadn't even, we found out there was a skip in this thing. And he hadn't even noticed a skip, right? And so what we did was we used the GTC 505. You can look this up on Amazon. You can buy one. And it's a little handheld ignition scope. That's all it's for is ignition systems. And boy, does it ever do a good job. And so I went ahead and grabbed that GTC 505, rested the wand on top of the coils till I found a high firing voltage on one coil. The plug was new, but it was greasy, and we put a new plug in there. It took about 30 seconds to locate a bad spark plug and another 5 minutes to replace it, and the skip was history. And we also checked the compression on that cylinder and rechecked the spark pattern after replacing the plug, cleared the codes. Now the second ignition quickie was a 2009 Camry that had developed an engine skip on number 1 and had tossed a primary ignition coil fault for coil A. The problem was that while the skip had been dead and present for many a mile, it stopped happening about the time the Camry made it to the shop, which is par for the course. Now I made a video on a similar one like this, or it might have been on this one, I can't remember. Since the GTC 505 was laying there with the box open after another job, I grabbed it to see what the pattern looked like after I replaced the coil. And the misfiring coil, when I checked it didn't look that bad. But when I ordered an aftermarket replacement coil from the parts store, it was an intermotor, as I remember. Put it in there with a new set of plugs, because this one had never had any, and it was only a few miles early according to the maintenance schedule. It still ran smooth, but when I checked the new coil with the 505, I saw 90,000 volts coming out of that new coil. That was ridiculous. So I reinstalled the original coil and saw less than 20,000, which was what the other 3 coils were reading. So I called the parts store, had them send a different brand of coil, and we installed that one. The pattern was normal after that. Then the parts store manager told me that the manufacturer of the first coil had said the Japanese cars require a higher voltage coil, and we had possibly wound up with those. I don't know what to make of that. I mean, maybe he was telling me maybe he was on the up and up or whatever, but that was just that didn't pass the smell test with me. But the lesson I gleaned from that Camry experience was that it's wise to double check after installing the new part. Just because you put another coil on there doesn't mean you can trust the amount of voltage it's taking to fire it. Even if the engine's not skipping, I was not going to leave a 90,000 volt coil on there. All right, so let me back up here. We already done that one. We looked at that one. That was the Subaru, and that was the Camry. Now this one right here, there was just enough back pressure to be a problem on this one right here. One of the things that we did was, he noticed it didn't quite seem to have the power it used to have, and so higher than scan tool resolution diagnosis was needed, because scan tools don't always give you the resolution you need. But nothing says clogged cat like a few pounds of exhaust back pressure. Using my tool to pull the oxygen sensor out, put the tool in there that had a nipple on it, put the hose on there, and I just use this plain old vacuum fuel pressure gauge. If you see that much pressure, that's what kind of pressure we had. See that catalyst? That caused us to have this much pressure. That caused him to lose power and fuel economy. All right. Now the next one we got, and we really looked at that, there was an ancient 4.6 liter coolant leak. This was at that program that I started over at the town about 25 miles up the road. And it was really a bear, running both those programs at the same time. I had to have an adjunct instructor to help me. But anyway, we're up here, and there was coolant pouring out of that valley on that, and so I had them pop the intake off, which you can do in about 25 minutes if you've done it a lot. And we got that off, and we saw this rusty coolant pipe. Now, the right way to fix this would be to replace the coolant pipe, but we didn't have a coolant pipe, and this lady needed this vehicle. And I said, we can try to fix this, and hopefully it'll be okay, but there's no guarantees on any of it. Well, the dadgum car was old and wore out anyway, and it was falling apart. So we went ahead, and we used a high-speed cutter to cut the rusty part out of that pipe, and we put a piece of rubber hose in there. It's a temporary repair, granted, and you know you have to. There's O-rings up here on the front of this too, so you have to have that thing. If the pressure is enough to where it pushes that pipe back and bends that hose, it can actually cause a worse leak than what you got. So you got to take special measures to keep it from causing a bigger problem than what you have. But you just tell the customer going in, this is what you're looking at. Okay, so this right here was one of those rare times when I had a student. The alternator bracket adjustment bolt had popped off in here, seized up and everything. And I said, we're going to drill that out, and then we're going to tap it. And that student just absolutely perfectly drilled out this bolt. I mean, look how that's a textbook drill out. I mean, I thought that was just really cool. And it was so good that I had to take a close-up picture of it. Of course, we drilled it out a little bigger, and then we ran a tap through there and all that. Anyway, this was another short video. We're running about 27 minutes here. And let me know what you think about this new format I'm using for these videos. And, we'll do something else if you don't like this, but just let me know. I'm looking for some votes on this. But I'll see you guys next week, and I appreciate you watching.